Right, I think it's time for another example. So in part B, let's solve hyperbolic cos 2x equals 3 hyperbolic sine x. Okay. So once again, this is a case 2 example. The reason being is we have a coefficient of 2, so it's not 1, it's 2 in our hyperbolic equation. So remember, if either the power or the coefficient of x is not 1, use the identity first and the inverse definition later to solve the equation in question. Okay, so let's have a look at this one. So in step number 1, we're going to be using, we're going to be using the identity hyperbolic cos 2x equals 1 plus 2 hyperbolic sine squared x. So remember, that plus arises from Osborne's rule. Okay. So if we replace in our equation, we're going to end up with 1 plus 2 hyperbolic sine squared x equals 3 hyperbolic sine x on the right hand side. And if I take all of my terms to one side, we're going to have 2 hyperbolic sine squared x minus 3 hyperbolic sine x plus 1 is equal to 0. Okay, so if I let t equal hyperbolic sine x to make it a quadratic, okay, we're going to have 2t squared minus 3t plus 1, and that's equal to 0. Okay, so we can factorise this quadratic, and if we were to factorise, the factors would be 2t minus 1 and t minus 1, that is equal to 0. And from there we have two values of t, so either 2t minus 1 is equal to 0, which means t is half, or another possibility, t minus 1 is equal to 0, which means that t is equal to 1. Okay, so I hope you can see that. So we've got two possibilities for the values of t. So in this case, these are the t values, but remember, t equals hyperbolic sine x. So since t is equal to hyperbolic sine x, okay, so when t equals half, first equation that we need to solve is hyperbolic sine x equals half. So I'll call that equation number 1. Or, so when t equals 1, so rather than or, let me just say when t equals 1, hyperbolic sine x is equal to 1, and we'll call that equation 2. Okay, so we have two equations to solve here to work out the x values. Now we'll call this step 2 because in step 2 we're going to be using the inverse definitions. Okay, so we're going to be using the inverse definition of hyperbolic sine to work out the corresponding x values. So over this to this side, so in step 2, so for equation number 1 firstly, we have hyperbolic sine x equals half. So hyperbolic sine x is equal to half. So x will be the inverse hyperbolic sine of half. So once again, you can use the HYP button in the calculator to help you calculate that value. So if you press HYP, it should give you a list of hyperbolic function, or you can use the definition that I explained in one of my previous videos. So remember, the definition of the inverse hyperbolic sine of x, that being ln x plus the root x squared plus 1. Okay, so we've seen that, and I've proved that in a previous video, so I'm going to use that definition to calculate the inverse hyperbolic sine of half. So by substituting that in, you should have x is equal to, okay, ln, so x, which is half, plus the square root, x, which is half, so half squared is a quarter, plus 1. So that's going to give us ln of half plus quarter plus 1 under the root is going to be root 5 over 4, but taking the root of 4 in the denominator will give us that 2. Okay, so I'll leave it as ln half plus root of 5 over 2. Okay, so that's the first solution for x. Now if we solve equation 2, so equation 2 is hyperbolic sine x equals 1. So let's come to this. So hyperbolic sine is equal to 1. X will be the inverse hyperbolic sine of 1. And once again, let's practice using this definition. So if we use the inverse hyperbolic definition of sine, replacing the x's by 1's, we're going to have x is equal to ln x, which is 1, plus the root of 1 squared plus 1 being 2. Okay, so in total we've got 2 solutions in terms of ln, and that completes the example. So here are the steps. So here are the steps in order to solve a case 2 example, or a case 2 equation. I hope you found this video helpful, and do related practice questions, and I hope to see you in the next video. Thank you.